Let's continue with question number 90. Find the equation of the straight line perpendicular to the line x plus 2y equal to 4, which cuts an intercept of 2 units from the positive y-axis. Hence, find the intersection point of the two lines. So when they're asking us to find the equation of a line perpendicular to this given line, I will use the concept that the slope of the product of the slope of two perpendicular lines is -1. So I can look at this equation and try to rewrite in the slope intercept form, which is y equal to mx plus c, and I will be able to find the slope of this line. And then I will be able to get the slope of the line perpendicular to this line. And another thing that they're telling us about the equation that we want is that that line cuts an intercept of 2 units from the positive y-axis. So this is the y-intercept given, which is 2. So if I'm able to find the slope and I also know the intercept, the y-intercept of the line, I can then use the slope-intercept form to find the equation of this line. So that's what we are doing here. This is one line given, x plus 2y equal to 4. If I rearrange and write, I will get y equal to minus 1 by 2x plus 2. So coefficient of x is minus 1 by 2. So slope of this line, let's say m1, is minus 1 by 2. And slope of the perpendicular line, let's call it m2, then m1 into m2 product is minus 1. Hence the slope of the line perpendicular is 2 units. Slope is 2, and then y-intercept of the required line is 2. And then if I apply the slope-intercept form, y equal to mx plus c, m2 and c2. So I will get y equal to 2x plus 2, and then just to write in the standard form, if I move y to this side, I get minus y. So 2x minus y plus 2 equal to 0. This is the required equation of the line. Now they're asking what is the point of intersection of this line and this line. So when they're talking about intersection of two lines and I know the equation of both the lines, I can just solve the two equations simultaneously and then find the solution. That x and y value in the solution is the coordinates, x and y coordinates of the point of intersection. So you can solve it whichever way you want, and if you solve the simultaneous equations, here I am doing a substitution. Previously I was having y equal to minus 1 by 2x plus 2. So this value of y I am substituting in the second equation, and I am getting a value of x equal to 0. And then x equal to 0, if I substitute in any one of the equations, I'll get y equal to 2. Therefore, the point of intersection of the two lines is 0, 2. Moving ahead to the next question. Okay, question 91. While preparing a PowerPoint presentation, triangle ABC is enlarged along the side BC to A B dash C dash as shown in the diagram, such that BC is to B dash C dash is 3:5. Find the ratio AB is to BB dash, length of AB if BB dash is 4. Is triangle ABC similar to AB dash C dash? Justify your answer. And ratio of area of triangle ABC and quadrilateral B dash C dash C. Now the first thing, when I look at this figure, I have to establish whether I have similar triangles. So I will look at part C first, that whether triangle ABC is similar to A B dash C dash. Now if I had triangle ABC given and I'm enlarging this triangle alongside BC to get this B dash C dash, then what will happen? I'm assuming that this enlargement happened in proportion. So if I compare ABC and A B dash C dash, they must be similar because the sides length should be in the same ratio. The ratio of corresponding sides of the length should be equal, and even the angles must be equal. Angle A is anyway a common angle, and BC B dash C dash must be parallel. That's how I have done the enlargement. Only then and if that is true, if these were parallel, if that's how I've done the enlargement, then B dash angle is same as B angle, C dash angle is same as C angle. So definitely these two triangles are similar. So that's the first thing I will answer, that since triangle ABC is enlarged alongside BC to A B dash C dash, BC we are assuming that it's parallel to B dash C dash and the sides are increased in the same proportion. So ABC triangle must be similar to A B dash C dash. Now once I've established that, I can write what are the ratio of corresponding sides which are equal. So these ratios are equal: AB by AB dash, BC by B dash C dash, AC by AC dash. And now they gave the ratio BC is to B dash C dash is 3 is to 5. So I can say that the ratio AB is to AB dash is also 3 is to 5. Now the question was asking what is the ratio AB is to B dash, but I have found out the ratio of AB is to AB dash. AB, let's say 3x, AB dash, let's say 5x. So then BB dash is actually AB dash minus AB. So 5x minus 3x, BB dash length will be 2x. So then AB is to BB dash is 3x is to 2x, which is 3 is to 2. So that's why I will say my answer AB is to BB dash is actually the ratio 3 is to 2. This is answer for the first part, part A. Now if suppose they are saying if BB dash is 4 centimeter, what is the length of AB? So I can apply this ratio AB by BB dash 3 by 2. BB dash, if you substitute 4, then AB value comes up to be 6 centimeter. Then they're asking about the ratio of some triangle and quadrilateral, for which I will go back to the pair of similar triangles. ABC is similar to AB dash C dash. And then if I apply the ratio of areas of similar triangles, area of these two similar triangles will be equal to the square of the ratio of the corresponding sides. And the ratio of corresponding sides was 3 is to 5. So square of that ratio is 9 is to 25. Now let's assume that area of ABC triangle is 9 units or 9y and area of triangle AB dash C dash is 25y. Then if I look at area of quadrilateral B dash C, this quadrilateral area is area of the larger triangle A B dash C dash minus area of the smaller triangle ABC. So the area of quadrilateral will be 25 units minus 9 units, which is 16 units. So therefore, if I am now looking at ratio of area of ABC to the quadrilateral, it will be something like 9y is to 16y. So 9 is to 16. That's the ratio of area of ABC and quadrilateral B dash C dash C. Moving on to the next question. This is from Maps and Models. So they have given a model of human eye and they're saying that the approximate volume of human eye, this is actual human eye, they're saying about 6.5 cubic centimeter, and the volume of a lab model excluding the base and stand of the human eye is 1404 cubic centimeter. You have to state whether the scale factor k is less than, equal to, or greater than 1. Now scale factor is the ratio of the length of your model is to your actual length. So if your model is larger than your actual object, then the ratio will be greater than 1. And in this situation, the model is larger than your actual human eye. If we look at the volumes given, volume of human eye is only 6.5, but the volume of the model is 1404. So the model dimensions are also larger than the actual object. So in that case, the scale factor is actually greater than 1. Since the model is enlarged compared to actual object, scale factor is greater than 1. In case model and object were the same size, scale factor will be 1 is to 1. And if the model was smaller compared to the actual object, the scale factor will be less than 1. Okay, fine. Next, you have to calculate what is the actual value of k, the scale factor. Then something about the diameter of human eye and the surface area of human eye. Okay. So let's start with what was the actual scale factor. Now, in the question, they have given us information about the volume of the model and actual human eye. So the ratio of volume of model and actual volume will be the cube of the scale factor, which is k cube. If I plug in the values now, k cube will be 1404 by 6.5, which is 216. So therefore, if I take cube root, k value will be 6, or the scale factor I can say is 6:1. Okay, then they are talking about if the radius, the diameter of the model, they're asking diameter of human eye, you have to find if radius of the model is 7.2. So we can make a comparison between radius of model and radius of actual human eye, and we know that the radius of that will be in the ratio of the scale factor, which is 6:1. So then radius of model was given as 7.2 centimeter. Let's say x is the radius of actual eye. So if I calculate that, I get x equal to 1.2 centimeter. This is the radius of actual eye. Therefore, diameter of actual human eye will be 2 times of that, which is 2.4 centimeter. And then they have given us something about the surface area. So we know that ratio of area of model and actual area will be the square of the scale factor. So area of the model was given 651.6, and they're asking actual surface area of human eye. Let's take y. So this ratio will be equal to 6 square of the scale factor, and if I calculate that way, I'm getting 18.1 centimeter square as the surface area of my actual human eye.